All right, we're going to do a 3.3a. It's solving by square roots, including complex number solutions. So these slides are going to just have a whole bunch of different examples and different ways of writing the answers. So, however, the process for solving using square roots is about the same. First thing you need to do is isolate the x squared. So if I'm going to solve this equation, isolate the x squared, I'm going to start by subtracting 23 on both sides. So using inverse operation, since it was plus 23. So on the left I have the 2x squared, and then 5 minus 23 will be negative 18. Continue by isolating. This is 2 times x squared, so divide by 2 on both sides using those inverse operations. So x squared equals negative 9. And then the inverse of squaring something is taking the square root. So when I have an x squared, to get x by itself, I have to take the square root. And whatever I do on the left, I have to do on the right as well. So I'm going to take the square root of negative 9. Now, as a reminder, if you had x squared equals 9, take the square root of both sides, you would get two answers. You'd get positive 3 and negative 3, commonly written as positive or negative 3, plus and minus 3. Because when you square 3, it equals 9, and negative 3 squared also equals 9. So that's why we get the two answers. Now, it's very similar when we're working with complex numbers. We're still going to get two answers for x, except for that when you square 9, you get 3. When you square root negative 9, you get imaginary 3, or written as 3i. So the square root of negative 9 is positive or negative 3i. Because remember, the square root of 9 is 3, and the square root of negative 1 equals I. So the square root of negative 9 is 3i. All right, this one's very similar, except for instead of just an x squared, we have this whole expression squared. So we're going to want to isolate this part before we can do any square rooting. We cannot distribute this 2 in here because in the order of operations, exponents would come first. So if we wanted to multiply by 2, we'd actually have to square this first, take x minus 3 times x minus 3, and that would make it much more complicated. So instead, we're just going to isolate the x minus 3 squared part. So first thing I'm going to do is subtract 8 from both sides to get this plus 8 over here. And it's going to leave me with 2x minus 3 squared equals negative 8. And this is 2 times this expression, so I'm going to divide by 2. And I'll get x minus 3 squared equals negative 4. Move that one down a little bit. Now, instead of squaring this, I'm going to take the square root. The square root then will cancel out that square. So I'll just be left with x minus 3. Whenever I do to the left, I also have to do to the right. So just like the square root of negative 9 was 3i, the square root of negative 4 will be 2i, and it's actually plus or minus, so positive imaginary 2 and negative imaginary 2. So plus and minus 2i there. Then notice on the left I still have one more step. I want to add 3 to get x by itself. Now here I'm making a complex number. I have a real part and an imaginary part. So I want to write that in standard form, which remember is a plus bi, where the real part comes first and then the imaginary part. So I'm going to write that as the real part 3, and then plus or minus the imaginary part 2i. And that's the shorthand way of writing it. But remember, that really means 3 plus 2i and 3 minus 2i. So you really have two answers there, plus 2i and minus 2i. All right, there'll be examples similar to this one later on, but the reason I included this one is because the x squared is second, so it confuses us a little bit, but the idea is the same. We want to isolate the x squared here. This is a positive 17 out front. So in order to move it to the right side, I'll have to subtract 17 from both sides. Because 17 minus 17 is 0, then the negative 4x squared comes down. Negative 19 minus negative 17 will be negative 36. They're both negative, so I can add them. Divide by negative 4 on both sides. We get x squared equals 9. Square root both sides. x will equal positive or negative 3. It's a positive 9, so our answer is a real number 3. Okay, another one like with the parentheses. So we want to get this expression here, x minus 2 squared by itself. So I'm going to start by moving that negative 21. Since it's a minus 21, I'm going to do plus 21 on both sides. Get 3 times x minus 2 squared equals 21. Divide by 3 on both sides. You're going to get x minus 2 squared equals 7. To undo that square, we're going to have to square root both sides. So that will take care of that squared. So you'll just be left with x minus 2. And the square root of 7 is irrational. It is actually approximately equal to 2.64, and then it just keeps going on forever. Because it's irrational and we want to leave our answers exact, we're going to leave it as the square root of 7. And it will be the positive, negative square root of 7. So both 2.64 and negative 2.64 approximately. I want to leave that as the square root of 7 though. Then I'm going to add 2 to get x by itself. And what this answer is going to look like, since 2 doesn't have a square root of 7, we can't add those together and say 3 square roots of 7. But what we do is we just put the 2 out front and then plus or minus the square root of 7 on the end. We don't want to put the plus 2 behind the 7 because sometimes we'll mistake this for the square root of 9. And so we want to avoid putting it at the end. So the 2 goes up front, and then it's plus or minus the square root of 7. So this is what the answers we want to leave in Algebra 2. Just so you better understand that, though, 2 plus the square root of 7 is approximately 2 plus 2.64, so 4.64. And 2 minus the square root of 7, well, approximately, that's going to be 2 minus 2.64, so negative 0.64. So these are the decimals. Sometimes it's easier to understand. This is how we want to write the exact answer in Algebra 2, 2 plus or minus the square root of 7. All right, running out of room here. The next example includes a fraction up front. So this was a reminder of what to do when we have a fraction. So I want to get this x squared or x plus 5 squared by itself. So I want to change this negative 1/2 into just a 1 so that this expression is by itself. In order to do that, you can think of it in 2 ways. Multiplying by 1/2 is the same thing as dividing by 2. So the inverse of dividing by 2 would be to multiply by 2. So multiplying by 2 on both sides, and more specifically multiplying by negative 2 since it's a negative 1/2. Or whenever you have a fraction, if you multiply that fraction by its reciprocal, in this case would be negative 2 over 1, multiplying a fraction by its reciprocal makes this equal 1 because you've got negative 2 times negative 1 is 2, and 1 times 2 is 2, and 2 over 2 equals 1. So essentially this is reduced down to 1, and 1 times x plus 5 is just x plus 5 squared. Then multiplying by negative 2 over 1 on this side is just negative 16, 8 times negative 2. From here we can do the square root to eliminate the square on the left. So we get, actually I don't even need the parentheses anymore. So it's just x plus 5 equals, now the square root of negative 16 will be imaginary 4, so plus or minus 4i. And so we want to subtract 5 to get x by itself. And remember, I want to put the real part first so that it's a plus bi. So it'll be x equals negative 5 is the real part, and positive or negative 4i is the imaginary part. And that's how we'll write our answer for that one. Okay, just a couple more examples. Here, I want to isolate x squared, so I'm going to start by subtracting 3 on both sides. Get negative 1x squared equals 28 divided by -1, I get x squared equals -28. And then I'm going to square root both sides to get x by itself. All right, two things here. First, the square root of -28 is going to be I square roots of 28, and both plus or minus I square roots of 28. That's taking the negative out first, and the square root of -1 turns into that I. Now the square root of 28, I'm going to need to simplify using my factor tree. So I'm looking for any perfect squares under 28. And 28 I know is 4 times 7, so 4 is a perfect square because it's 2 times 2. So the square root of 4 here is 2. I can take a 2 out front. That 2 is going to go in front of the I, and then the 7 is left back inside the square root. So it's going to be 2I square roots of 7. And -2I square roots of 7. And we could write that as plus or minus 2I square roots of 7. So the 2 that comes out goes in front of the I, and the I goes in front of the square root. And one more here. This one, in order to isolate the square root, x minus 3 squared, I'll have to start by dividing by 2 on this side. I'm going to end up with x minus 3 squared equals 4. To undo the square, I'm going to square root both sides, and I'm going to get x minus 3 equals plus or minus 2. Square root of 4 is just 2, real number 2. Then to solve for x, I'm going to have to add 3 on both sides. And now the most common answer that I get from students is plus or minus 5. And I threw this example in here because I want to show you how it's not plus or minus 5. Now, we have 2, plus or minus 2 really means positive 2 or negative 2. Well, positive 2 plus 3 is 5, but negative 2 plus 3 is 1. So our answers are actually 1 and x equals 5. So we actually have two completely different answers. Here we have 1 and 5. So remember, when you get a real number square root, you have to break it down into each part and do the addition or subtraction separately. And I guess this is my last example. So I'll start by subtracting 1 on both sides. Get 9, w minus 4 squared equals -1. Divide by 9. Going to get w minus 4 squared equals -1/9. Now, -1/9 is 0.11 repeating. I'm going to leave it as a fraction. And when I square root, you'll see why I left it as a fraction. Because when you square root a fraction, you can actually square root the top and square root the bottom separately. So on this side, the square and the square root cancel, and I get w minus 4. Well, the square root of -1 is I, and the square root of 9 is 3. And it is going to be plus or minus I over 3. Now I'll need to add 4 to both sides. And I want to write my real part first. Again, a plus bi. So this will be w equals positive 4 plus or minus I over 3. Or that could be also thought of as 4 plus or minus, it's 1/3 I is the same thing, 1/3 I. Because it's 1I over 3. All right. And that's it. So just remember, you can pause it if you want to try another example again, but make sure that none of that works with that. So just make sure you're isolating the x, whatever is being squared, and then square rooting it from there. All right, let me know if you have questions. Thanks for watching.